Okay. Hi guys. Good morning. Welcome to functions class. Today I am going to show you how to solve this special indicial equation with trigonometric exponents. Okay. Without wasting much time, I okay. Before I forget, please don't forget to subscribe to my channel if you haven't done so. Like and comment for the video to go far. All right. Without wasting much time. Anytime you encounter a problem like this, 32 raised to the power of tan square x or 32 sec square x equals to a value. And you are asked to solve for the value of x. Now, from trigonometric point of view, I'm going to show you where this and this really relates. There's where tan and tan theta and let me put the square and sec square x are deeply related. Deeply related. So you pick the formula from there. So what I'm going to do, I want to start it from the primary trigonometric identity where the whole system starts. We know that the square of the sine sine square plus cos square of x equals to 1. Now I'm going to divide all through by cos square. Divide across, let's call this equation 2. Divide 2 by cos square x. So that means sine square x over cos square x plus cos square x over cos square x equals to 1 over cos square x. So, okay, I will still recall from secondary trigonometry, the 1 over cos is equals to sec. Okay, so if I put x here, that will be sec squared. So also sine over cos also plug that here. Also sine x over cos x equals to tangent of x. That's the weird stuff. So where you have sine square x over cos square x plus cos square x over cos square x equals to 1 over cos square x now will become tangent of square x plus the same thing divided by the same thing is 1. Remember, 1 over reciprocal of cos is sec. So reciprocal of cos square is going to be equals to sec, right, of x. So look at it. We've gotten that thing we needed. So we can, if you like, can just make one of the subset of the formula. I can either say that the sec, like you can see, is equals to 1 plus tangent. I say it's equals to this. Or I can also say that uh, the tan square of x is the same thing as sec square minus 1. Any of them can go. So from equation 1, we have that 32 raised to the power of tan square x plus 32 raised to the power of sec square x, okay, equals to 9. So I'm going to write one of these in terms of another. So I don't know, I can take any one of my choice. If I make sec, I can take this to replace sec since this is equals to sec. So that's what I'm going to do right now. I'm going to write 32 of times square x equals to 30, sorry, plus, okay, plus 32 of, instead of me writing sec square x, I'm going to write tan square x tan square x plus 1 equals to 9. All right. So now I'm going to, this is the law of indices. If I have a raised to the power of b plus c, it's same as a raised to the power of b times a raised to the power of c. So I'm going to write this place as 32 times square x plus here is where this law of indices coming. 32 raised to the power of tan square x times 32 raised to the power of 1. Okay, so no need to put that, still equals 9. So, and at this point, you can see we have a common term in the common factor in both of these first term and second term of the left-hand side expression. So I'm going to factor out what is common. I'm going to factor out 32 raised to the power of tan square x into, if I do that, I have 1, and plus I have 32 in this other side, raised to the power of 1, which is still going to be equal to 9. So, and okay, so we have 32 raised to the power of tan square x into 1 plus 32. That's what we got, equals 9. So now we can say 32 is power of tan square x times 33, okay, equals to 9. Now we can divide all through by this 33 to make this place stand alone. 33, 33, the 33 cancel 33. We have 32 raised to the power of tan square x equals to, can reduce this fraction. 3 compare 3, 3 compare 11. So you have 3 over 11. Okay, so at this point, I just want to make things a little bit easy for myself. I can write 32 in Indicial form. I will write 2 raised to the power of 5 in uh, tan square x equals to 3 over 11. All right, so that really make work much easier for me to deal with. So I will, the next thing there is to open the bracket. I'll have 2 raised to the power of 5 tan square x is equals to 3 over 11. All right, so what we got there is 2 raised to the power of 5 tan square x equals to 3 over 11. So you can confirm that there. All right, so we have the next thing here that can help us to deal with this person is the logarithmic kind of transformation. So I would take log of base 2 to both sides. So both sides of the equation. So that will be log of base 2 of 2 is to the power of 5 tan square of x equals to log of base 2 of 3 all over 11. Okay, and this will become, remember, in law of logarithm, we have a b raised to the power of c is the same thing as c log a, okay, like that. So the power of the log number of the logarithm becomes the factor that multiplies the logarithm itself. Okay, that means the entire power here, will turn out to become the factor of the logarithm. So let's go. So that will be 5 tan of square x times. So let's put that in bracket. Log of 2 plus 2 now is equals to log of plus 2, 3 over 11. Remember also that if the number and the logarithm, the base of the logarithm is the same, that logarithm is equal to identity 1. So that means this place is the same thing as 5, the same thing as 5 tan squared x times 1 equals to log of 3 all over 11 and the base of 2. Okay, so right now, if I use 1/5 to both sides, multiply the reciprocal of 5 to both sides. Let me put that here. Multiply 1 all over 5 to both sides of the equation. If you do that, you have 1 over 5 times 5 times square x equals to 1 over 5 log that's 2, 3 over 11. So this 5 will take care of this 5, and what we have the left is tan square x on it. So we have tan square x now equals to 1/5 of log that's 2, 3 over 11. All right. So now this is a square. I want to tell you that another way to write this is tangent of x or square equals to 1 all over 5 log base 2 of 3 over 11. Okay. And to remove square, we introduce square root to both sides of the equation. So that can be equals to tan x equals a positive square root of 1 all over 5 log of base 2 of 3 over 11. Okay, so I can say that to take off this tan, we introduce tan inverse to both sides of this equation. We have tan inverse times tan of x will be equals to tan inverse of square root of 1 over 5 log of base 2 of 3 over 11. Okay, so this and this become x. So x, therefore, is equals to tan inverse of square root of 1 all over 5 logarithm of base 2 and 3 over 11. So I believe that solution really help in this problem. All right. Thank you. And if the lesson helps you in any way, don't fail to comment and subscribe to the channel um, for so that you'll be able to see more of the video that will be coming each time. Okay, thank you and have a nice day.